Our job this time is to simplify the following expressions. They are all indices. So let's see how far we can apply the rules we've learned earlier to solve these problems we have right here. The first one is x squared times x to the power of 5. Very important, you should know that when x is squared, it simply means we're doubling x, right? So you can decide to make it x times x. That's what x squared means. And this we're multiplying by 5x's altogether. That is, remember this is multiply, okay? So this is going to be 1x, 2x's, 3, 4, 5. This is a very simple way of solving this kind of problem. So the very next thing I'm going to do to get my answer here is to count. So for me to count, I simply have to count 1, 2, 3, 4, 5, 6, 7. That's 2 plus 5, right? So it means that the total number of x I have is 7. So my answer is x to the power of 7. It's as easy as that. Another simple way to do it to make your work easy instead of counting is to simply say, since the bases are the same, x, I take it out, x. Now I add the powers, 2 add 5. So it's going to be that 2 add 5 is 7. So my answer ends up being x to the power of 7. This is as easy as that. You got it? Okay, let's try it out in the next example. The next example has a to the power of 6 divided, not multiplied this time, divided by a to the power of 4. So how are we going to do this? Now, the only difference between this example and the first example we solved is the division sign. So we can also apply the same rule. I'll make it a bit easier for us, okay? So what I'm going to do? You can try working out a in 6 places like this. A1, 2, 3, 4, 5, 6. The points I'm writing in between them represent times, okay? Divide. One way of writing division sign is the fraction form all over, like this. Then I'm going to write the remaining one. A1, 2, 3, 4. Okay, now it's time to cancel out. Let's do the canceling process. Now I'm going to remove one up, one down. They go together. One up, one down. They go together. One up, one down, and one up, one down. Since I've removed all these, how many do I have left? I have just double A. That's A double. Okay, so I'm going to write A squared because I have A two places. That's it. That makes your work easy, right? But when you have very high powers, this method of counting becomes time consuming. And because we don't want to consume all our time, we try to apply the rules directly enough. So if I apply the rule directly enough, since it's division sign with exactly the same base, all I will need to do is simple. So I'm going to say a to the power of 6 minus 4. 6 minus 4. Remember, when you are dealing with division of the same bases with different powers or the same powers, it has to do with the same base and then subtract the powers. So my answer is going to be a to the power of 6 minus 4 is going to give me 2. So we end up having exactly the same answer. Let's try solving b to the power of negative 4, everything altogether raised to the power of 3, or everything cubed. Okay, if we decide to work with the powers we have here, first of all, it simply means we are going to do with b to the power of negative 4 three places. This is what I mean. B to the power of negative 4 one place times b to the power of negative 4 the second place times b to the power of negative 4 the third place, right? Yeah, that's how it's going to be because we have applied similar thing here. So if that be the case, it's time to add them, right? We're going to add b to the power of negative 4 plus b to the power of negative 4 plus b to the power of negative 4, the way we added them earlier. So if we apply our knowledge of addition of negative numbers, I'm going to say b to the power of negative 4, add negative 4 again, add another negative 4, right? So how is it going to be? Addition of negative numbers is simply the total addition of the numbers in a negative form. So my final answer is going to be b to the power of negative 4, 1, 2, 3. It's simple. It's the same thing as negative 12. I can leave my answer this way, or I can choose to take it a little further by simplifying this because this is negative power rule can be applied here, right? So if I go further, I can leave it as 1 divide b to the power of 12 without writing the negative number. You can leave your answer like this. You can also write it this way. Since 1 to the power of anything remains 1, you can write it 1 divided by b, close the bracket, everything raised to the power of 12. It's also the same answer. Yeah, it's the same because if you express 1 to the power of 12, it remains 1, while b to the power of 12 remains b to the power of 12. So if you write your answer like this, you're correct. You write it like this, you're correct. You write it like this, you're correct. Then there is another way to solve this problem to make it easy for you instead of going through these rigorous processes I've just gone through. Let me show you what I mean. Let me use red this time to differentiate, okay? So instead of going through this long process, you can simply say you're solving this by saying b to the power of negative 4 multiplied by 3. Yeah, this is multiplying two powers together. And if I do that, it leaves me with b to the power of negative 4 times 3 is negative 12. Your answer comes back. And you can choose to express it this way or this way. Whichever way you choose to leave it is your choice. But the most important thing is that you know what you're doing, right? It depends on what the question requires you to do. Now, this is the connection between the left-hand side and this side, right? So it's still the division that we did in the previous question that we just solved. So what I'm going to do now is, first of all, this is going to make my numerator. So I'll make it this way, minus 5x to the power of 4, y to the power of 6. This is my division sign like this. And my denominator is negative 10x to the power of 3 upon 2 and y to the power of negative half. Yeah, something like this. This is a good step to start. Now, I'm going to make my work easy somehow. See the way I'm going to make it. There is up, there is x up here, there is x down here, there's y up here, there's y down here. See, I'm just going to separate the numbers together, the x's together, the y's together somehow. So I'm going to do something like this. Negative 5 over negative 10, they can stay together. Then times x to the power of 4 divided by x to the power of 3 upon 2. They can stay together times y to the power of 6 divided by y to the power of negative 1 upon 2. They are still together, right? So we are going to apply the simple division rule that we already know here. So see what I'm going to do. For this case, if I want to divide, negative cancels out negative. So I have 5 upon 10. If 5 cancels out 5, I have 1. 5 cancels 10, I have 2. So I have half. I'm writing it down. 1 upon 2, multiply. Now see, I'm going to apply the division rule here. So it's going to be, take the same base, which is x raised to the power of 4 minus 3 over 2. You minus when you are dealing with division, okay? And times, this case, the base is the same as y. So I'm going to raise it to the power of 6 minus negative half, like this. Okay, so let's solve it out. This is going to make our work easy. Half remains half. I'm going to write it a bit bigger this time. Okay, half times, let's do this. This is a fraction we're going to simplify. So it's going to be x to the power of 2 times 4 is 8, and 8 minus 3 is 5. So it's going to be x raised to the power 5 over 2, yeah, times y to the power of, let's simplify this. Negative multiply negative is plus, right? So if you want to simplify this, it's going to be 2 times 6 is 12 plus 1, right? So 2 times 6, 12 plus 1 is 13. It's going to be 1, 3, all over 2. Something like this. So I can express my final answer this way. I can simply say my final answer is the same thing as, let me write it here. I'm going to do it with a different color since this is my final answer. Let me write with a dark blue or just a light blue. Okay, light blue is okay. I'm going to write it as half, okay, x to the power of 5 over 2 and y to the power of 13 over 2. If you leave your answer like this, you are very correct. No problem with that. Perfect. Or you can also decide to express it this way. I'm going to write it in fraction form. So if I want to write it in fraction form, 2 is going to be our denominator. As you can see right here, why everything is a numerator? Because I'm multiplying 1 by x by y, right? So 1 multiply x and y together remains x and y. Therefore, I'm going to write like this. X to the power of 5 over 2 times y to the power of 13 over 2 Yeah, everything is all over 2. This can also be my final answer. So if you keep it this way, you are perfectly correct. And if you keep it this way, you are also perfectly correct. I hope this video has helped you to understand how to apply the rules that you learned earlier on how to operate indices. Give us a thumb up, please. Like this video and turn on the notification bell so that when we upload our next video, you'll be the first to see it. As always, thanks for watching.